First, I want to introduce Jim as a good friend. He's been a friend of mine since I've been going up to Franklin, and just a wonderful guy. And I'm so glad he could come tonight and speak to us, especially on such short notice. So thank you, Jim. James Van Fleet has retired many different endeavors, science, engineering, librarian at Bucknell University. He's been the president of the Franklin-Ogdensburg Mineral Society, which is near and dear to my heart. He's also been the editor for the for FOMS, which is the FOMS journal, the picking table. Jim has done endless amount of work for the Franklin-Ogdensburg Mineral Society. Every show that I've ever been to, he's been there helping. Just a wonderful guy. He's been editor of the Fluorescent Mineral Society, which I'm a member of. And if you like fluorescent minerals, I definitely suggest joining that. He's also been the editor of the Picking Table, which is the publication by FOMS for the Franklin-Ogdensburg Mineral Society. So he's done his share of work for sure. He's also been the editor, or one of the editors, of the Van King book, which is the Holy Bible on Franklin minerals. And there's 3 copies, and I think it's about $300 for all 3 books. But they are just the most colorful and fantastic fluorescent mineral books you'll ever find. And not only that, they have the daylight minerals. So that being said, Jim, I'm going to turn it over to you.
All right, I'm going to try and share my PowerPoint presentation. So talk about collecting Franklin fluorescent minerals. Just a brief, very brief, where are we? The Franklin mine in Sussex County, New Jersey, and just a mile and a half from it, Sterling Hill mine in Ogdensburg. The fluorescent mineral capital of the world, according to the New Jersey State Legislature. As you can see from the geology map, the Franklin mine is in the Franklin marble. It's a limestone and completely encases or surrounds the ore body. And nearby, you've got Mine Hill and this area over here where there were lots of iron mines, Balls Hill, and you can see little X's here, little hammer and gad that indicate the iron mines. So here's the Franklin ore body and all of those iron mines along that contact between the gneiss and the limestone. They mined for iron ore from as early as the 1740s. The zinc ore, though, was not recognized until 1810, when samples were sent to Europe and the European chemists and geologists identified zinc. In fact, before that time, it wasn't uncommon for the miners there to take and try to smelt the zinc ore, and it would not smelt. It was not like smelting iron. It would actually form what was called a salamander, a giant blob of melted ore, and it would basically wreck the lime kiln. They'd have to pull the kiln apart and pull the salamander out. It took them a while to get it right. There were many different small mines. They were consolidated into the New Jersey Zinc Company just at the turn of the century. And they continued in production until 1954. They combined to produce over 22 million tons of zinc and iron ore. Sterling Hill is south of that, also in the limestone. And for people who are familiar with the place, there's an outcrop of the ore right here at what they call the keel, where some of the ore outcrops on the surface. Folklore claims that the Dutch noticed the zinc. They saw this red, earthy ore, and they thought that it was a copper ore. So again, it was misidentified. They produced until 1986. Sterling Hill produced 11 million tons, and they left 1 million tons of ore in the ground. They had to close the mine because of tax problems with the township. There are some surviving mine structures, a conveyor and some ore bins. These openings underneath here was where the train cars would pull in. There was a railroad. Trains would pull in and be loaded with ore. Here's the adit. Goes straight back into the mountain. And you can see the angle of this car here, the ore car. Actually, that's a man trip that was used for lowering miners into the mine. You can see the angle that it's at. That's the angle of the entire ore body going down over 2,000 feet. If you take the mine tour, you'll get to see the Houck brothers in all their bronze glory. And there's the adit underground, straight back into the mine. They have a wonderful museum. They took the cages, the change house where the miners used to change their clothes, and they turned it into a museum display. But what makes Sterling Hill and Franklin unique? Almost 7% of all the minerals found in the world can actually be found in this one place. 71 minerals first described from Franklin and Sterling Hill. 19 of them have still not been found anywhere else on Earth. Zincite and Franklinite and willemite are very famous as the ore minerals, and this is the only mines where they are the primary ore. Most zinc mines, the primary ore is actually sphalerite. And over 90 fabulous fluorescent species. Probably everybody's favorite, Kenny's favorite, my favorite, green willemite. This is a very pure piece of gemmy, what they call gemmy green willemite. And this is what it looks like under shortwave UV light and under longwave UV. So why gemmy? Well, because you can actually cut it and facet it into gemstones, and they fluoresce too. Another example of green willemite with zincite, that's the red mineral here. Franklinite is the black little crystal segments. Another piece of willemite, zincite, and franklinite. And that's what it looks like in daylight. So it's very bright green. Some people say if you take this willemite out on a sunny day, you can actually sort of see it fluorescing just under the UV light that's in sunlight. But that's shortwave UV. And again, long wave. This is a slightly different variety. They call it sea foam green. You can see it's cherty, has a little different texture and color, but also very, very fluorescent. You'll find willemite veins in ore. Grape willemite, actually kind of a purpley color mineral. Still willemite, still fluoresces green. It comes in yellow, long wave and short wave. Brick red, kind of a tan. Some people call this caramel willemite. Dark brown, pink, gray willemite. That's a crystal. And black, due to inclusions. They think this is due to a lot of inclusions of franklinite, and it's not very fluorescent, but it does fluoresce green. I think this is Ken's favorite. Willemite, radiating white, acyclic, needle-like crystals of willemite that fluoresce brilliantly, and they also phosphoresce. Another example of the radiating habit. And that's a picture of it phosphorescing. And some of these will actually phosphoresce. After you take the UV light source away, they'll continue to glow for hours. Notice the blue on this specimen here. It's not blue willemite. It's Vesuvianite, cyprine, with willemite X solution. And I'll talk more about X solution a little later. But basically, the cyprine is completely saturated with the willemite so that it does fluoresce. Another funky one, this vein down here, which looks like a breccia actually, is not blue willemite. It's a mineral called ribachite or magnesio-ribachite, but it's completely full of willemite, so it fluoresces. There's a variety, this pinkish, druzy crystalline stuff here, they call beta willemite, which actually fluoresces yellow to orange and phosphoresces a kind of a tan color. Really interesting stuff. So let's move on to another mineral, salmon calcite. Calcite is the most common skarn mineral in the Franklin and Sterling Hill deposits. And they call this salmon calcite obviously for a reason. It looks like a chunk of raw meat and fluoresces very pretty red. Another example of salmon calcite, you could see the rhombohedral cleavage and nice fluorescence. Fire engine red, we call it. What we call crazy calcite, and this is from Franklin, and it's calcite and dolomite, and it has that lovely two-tone combination and tiny little grains of franklinite all throughout it. We call it salt, pepper grains of franklinite, as distinct from the crazy calcite that you find at Sterling Hill, just down the road. Calcite and dolomite, but instead of small grains of franklinite, it has amphiboles in it and some other minerals. It's a little coarser looking, but again, a pretty fluorescent mineral. The calcite can come in multi-wavelength, sort of a terlingua type calcite, shortwave UV, midwave, and longwave. Very distinct, different fluorescent responses. This piece of calcite has a thin coating of willemite on the calcite. And under longwave UV, they combine, the two colors combine to form a kind of a peachy yellow. Sterling Hill boasts some nice calcite crystals, what they call water crystals, nail head shapes, calcite crystals that do fluoresce. Sorry about the dust, I guess you'd call it in here, the detritus. It's very hard to find a specimen from Franklin and Sterling Hill that doesn't have willemite dust on it, and the stuff is very tedious to get off. Hemimorphite, also from Sterling Hill. This was an ore of what they call calamine. 150 years ago, this was one of the primary ore minerals from Sterling Hill in an area that they called the mud zone. And they basically mined it out. They mined a couple of 100 feet down and just created a huge pit, which is now the Passaic pit that used to be full of calamine or hemimorphite. Its fluoresces a kind of a dull green. Just an example of microcline feldspar with calcite in it. Nice combination of colors. One of the big three, of course, is the willemite, calcite, franklinite. Franklinite doesn't fluoresce. So if I had to say that a third really important fluorescent mineral from Franklin only, not Sterling Hill, would be Hardystonite, which is this kind of off-white looking mineral on this rock. Fluoresces a brilliant violet blue. Very popular fluorescent mineral to collect. Here's another example of Hardystonite with tephroite full of X solution willemite. What happens here is that as the minerals are forming, the tephroite can't accept the zinc silicate. And so the willemite is literally squeezed out of that mineral and forms little dots or lines. And so we've got two minerals going on here, the tephra and the willemite, side by side or intermixed. But that's a very lovely piece of hardystonite. Hardystonite can alter to clinohedrite. So you'll see that happening here, thunderbolt veins and surface coatings. Willemite reaction rims around the franklinite. Some interesting geology going on as well as the fluorescence. I think this is another example, yeah, of hardystonite altering to clinohedrite. Some people collect what they call mimetoliths. That is rocks that look like something else, that have a certain shape. Maybe it looks like a ghost or it looks like a chicken. This one looks like a sneaker. Norbergite is a yellow mineral, and phlogopite mica, and you'll see lots of little grains of graphite in this piece too. This is actually from a quarry. It used to be called the Franklin Quarry or the Farber Quarry. It's on Cork Hill Road, exactly halfway between the Sterling Hill ore body and the Franklin ore body. So this is in the marble, the Franklin marble that surrounds the ore bodies. And there are fluorescent minerals to be found there as well. Another one would be fluoborite, which fluoresces kind of a cream white. Wollastonite from Sterling Hill usually fluoresces a nice orangey yellow to yellow. This one has what they call the green eye. In the very center of some masses of wollastonite, you'll see this greenish tinge. There's a piece of orange yellow. The calcite is red. There's some hydrozincite blue fluorescent coating there. And here's a much more yellow example, and the calcite doesn't fluoresce as much. It's an interesting mineral to collect from Sterling Hill. If you're right up close to the ore body, the wollastonite is almost orange, orangey yellow. And the further you get from the ore body, the calcite stops fluorescing and the wollastonite gets more yellowish. It is a very yellow piece, hardly any calcite in it at all. And here's a piece that's almost, I don't know, pale, I guess you'd call it pale yellow to pink. For Sterling Hill mineral collectors, there's some debate about whether this is actually from Sterling Hill. You'll find it there, but there was a point in, I think, the 1930s or 40s where a load of wollastonite from upstate New York was transported down to Sterling Hill for study. And I think some of those pieces wound up on the dump. Now, the Franklin mine up the road also has wollastonite. This example is called Third Find. It's the nice orange wollastonite with small blebs of barite, fluorescing white, and the calcite matrix fluorescing a nice bright red. There was a first find and a second find in the 1940s, but those are very, very rare and hard to come by. Third find is something you would actually find if you went looking for it. There's also what they call fibrous wollastonite. Again, this is kind of disseminated in the rock. There's some calcite, there's some willemite. They make for very pretty fluorescent specimens too. Aragonite from Sterling Hill, nice radial sprays that fluoresce. And again, the ubiquitous willemite dust, which goes away in the long wave. You don't see it so much. That's a pretty long wave fluorescent. Bustamite with green willemite, the pink mineral here. Doesn't do much under short wave. This is long wave UV. And this is using a long wave flashlight. I suppose most people by now have seen these. The long wave high intensity 365 flashlights, Convoy or what have you, that really put out a lot more light. They excite the minerals quite a bit. They make them brighter, and they also make them phosphoresce for a longer period of time afterwards. Barite from Sterling Hill, nice white fluorescent mineral usually in a calcite matrix. It's found on several levels in the mine. Barite from Franklin, you'll see looks much more massive. It's not small blebs, it's bigger segments in the ore. Esperite is a very famous fluorescent mineral. See a nice band of esperite here, fluorescing bright lemon yellow. It's hard to say whether this is willemite altering to esperite or esperite altering to willemite, but there's some reaction going on there. Another example of esperite. Esperite with zincite and franklinite, and the hardystonite, the nice blue fluorescing mineral. And sometimes you'll see those interacting as well. Apatites, interesting case. They're the most complicated mineral supergroup from Franklin Sterling Hill with 5 confirmed species. Recent article in the picking table confirmed sphabite and johnbaumite. Fluorapatite is typically blue, can be massive like this or crystalline, and fluoresce a kind of a burnt orange, we call it. Hetephane is the lead apatite. Doesn't do a thing under shortwave UV, but under midwave, it fluoresces an interesting orangey red. Johnbaumite is, again, it looks like a blue apatite mineral, but it fluoresces a nice pumpkin orange. Ternurite is the rarest of the apatite minerals at Franklin. It's usually found in salmon calcite matrix. And again, fluoresces a really bright orange. Scheelite is found at both Franklin and Sterling Hill. This is a Franklin example. Just blebs. You're not going to find massive pieces. You're not going to find anything that looks like the Trumbull, Connecticut stuff. And it tends to be a little more yellowish than scheelite found in other places. But it's an interesting mineral because it doesn't require any activators, any impurities in order to make it fluoresce. Scheelite is a pure mineral that will always fluoresce. There's axonite, manganaxonite, fluorescing a nice red. And everybody's favorite, margarosinite. Hard to come by and quite pricey nowadays. But here's margarosinite on a manganaxonite matrix. And that sky blue fluorescence is really distinctive. This is a rock in my collection, but Van King photographed it for the big color book that Kenny showed us earlier. And you've got the margarosinite fluorescing both blue and red, a mineral called zonotlite, Xonotlite, right? Zonotlite, clinohedrite, willemite, all in the same rock, all in the same face, which is kind of nice. Prehnite pectolite. The prehnite is kind of bluish, the pectolite orange. There's my zonotlite. It can be a powdery white surface coating, but it fluoresces a very pretty purplish blue. Native copper is found at Franklin, not at Sterling Hill, in sheets and leaves. And you can tell it's from Franklin because when you lamp it, it's got willemite all through it, tiny little needle-like crystals or grains all through the copper ore. Nasonite is a fluorescent mineral. This is the prehnite and pectolite orange. And then the nasonite is this ugly blue-gray fluorescent mineral. But there it is. It's fluorescing. Quartz can fluoresce. And this is an interesting example of I guess I'd call it a chalcedony kind of a coating on ore, fluorescent green. Ganthelvite is a rare mineral from Sterling Hill and Franklin, but this is a Sterling Hill example. It does not fluoresce well under shortwave, but under long wave, it's much brighter than the calcite or the willemite. Cuspidine is a Franklin mineral that highly sought after, kind of a mustard yellow in shortwave, and a more yellowish orange under midwave. Dipingite is a neat little mineral. If you see these little spherules on the rock, some people call them railroad tracks. They fluoresce blue in shortwave. You can just see them through the willemite, but much brighter in the under long wave. Here's an interesting mineral, snookolite. I've put the formula up there. It's actually a uranium mineral, and it's a post-mining mineral. It was found on the 2,200-foot level at Sterling Hill by Dick Bostwick. And he calls it snot on a rock. And it's just this greenish surface coating that was deposited after mining stopped. And it fluoresces a uranium green, no surprise. Roeblingite, very rare mineral. This is a tiny little 1 inch by 1 inch nodule with a couple of exposures of this, what we call a coconut kind of porcelain looking mineral that fluoresces a bright red. But it's not just about the pretty colors. As I said, fluorescence can reveal highlights, interesting geological features and textures, minerals that aren't obvious in daylight. The fluorescent minerals can be deposits or intrusions or alterations or weathering products. Franklin gneissic ore, very famous for the gneissic banding. And this occurred, you can find it in small pieces, but it also occurred on a very large scale. The entire parts of the entire ore body have this gneissic banding going on. And that fluoresces nicely too. Sterling Hill, they have what they call myelinite, and that is ore. We saw some earlier pieces that had grains of franklinite and grains of willemite in them. In this piece, the grains have been flattened and stretched by faulting, and there's a lot of faulting at Sterling Hill. And the result is a really pretty fluorescent pattern. There's collapsed breccia, which is actually a karst feature. Gaps in the deposit in the ore body get filled in with sediment, and the sediment happens to be clasts of calcite, willemite, other Franklin minerals that form these breccias. This is an interesting piece. The matrix is aegirine or augite or diopside, and it has these rounded little chips of calcite and willemite. And this is what they call Christmas tree rock, because it really does look like Christmas ornaments. So that's the real deal. The poikilotic texture is Christmas tree rock. Hardystonite can form crystals, rock-locked rectangular crystals. They're very rarely freestanding. Remember I mentioned X solution before. The green mineral is peat dunite, the green daylight mineral, and you can see tiny little moss-like dots of willemite all through this, where they have been exsolved out of the peat dunite, and now they're two separate minerals sharing the same space. X solution can take an interesting turn. This is tephroite with X solution, where the willemite has been squeezed out as very thin lamellae. And so we call this a circuit board fluorescence, willemite in tephroite from Sterling Hill. Hydrothermal veins and intrusions are very common. Under shortwave UV, this one is only obvious because it doesn't fluoresce. But under long wave, you see that it's a vein of sphalerite. And actually the ore on either side of it, the fluorescence has been quenched by the heat of this hydrothermal fluid intruding in the ore. There are lamprophere basalt dikes at Franklin, and this isn't a vein of ore. This is actually a sandwich, a piece of ore that has been broken loose and sandwiched between two layers of the basalt, the lamprophere dike. Hydrozincite is a weathering product. Nice blue fluorescence. You'll find it wherever you find sphalerite. The long-wave flashlights, as I mentioned, they're lower cost, higher intensity. They induce stronger fluorescence and phosphorescence. They work great on fluorite from Franklin. It's a chlorophane fluorite that fluoresces a kind of a teal green, blue-green. Shortwave and longwave, and phosphoresces too after the lamp is taken away. This is sphalerite from Sterling Hill. Some miners called it shines because it really does shine brightly in daylight, but it also fluoresces very nicely. Shortwave and longwave. Sphalerite with talc, both fluorescent. Shortwave and longwave. Some of the sphalerite veins call this mahogany sphalerite. You can tell just from the texture, it almost looks like mahogany wood. Again, shortwave, not much, but longwave, very bright. Golden sphalerite. I don't think I have a shortwave picture of this one, but you'll see why it's called golden under longwave UV. Just an amazing color. Cleophane sphalerite is iron-free sphalerite, and it fluoresces more blue and purple. Shortwave, longwave, and then under the longwave UV flashlight, even more blue. So you'll see the red in here, the zincite, and a vein with zincite in it. Shortwave doesn't look like much, but longwave, the zincite actually fluoresces yellow. And so you'll get some of that yellow, some pinkish sphalerite, and very pretty colors. So talk for a minute about collecting sharp crystal specimens from Franklin and Sterling Hill. Franklinite has just been named the New Jersey State Mineral. So now sharp crystal specimens of Franklinite are more desirable and harder to find. Here's an example of the nice octahedral shape and a smaller crystal. Not a twin, but just a nice combination. A trustite, which is a tan willemite hexagonal crystal with franklinite crystals, and zincite. It's a really classic specimen there. Fluorescent red and green. This is a crystal, a large crystal of black willemite, which again doesn't fluoresce very well. And the gray, which I mentioned before, that's a fairly large crystal. I realized after I had put this together, I should have put dimensions on a couple of these or put a ruler in the picture so you can get a sense of how big or small they are. I'll show you this one in person when the slideshow's done with. Rhodonite is one of the few minerals from Franklin that collectors love to collect, even though it does not fluoresce at all. So here's some nice hexagonal and tabular rhodonite crystals. What I call mining artifacts. Of course, all of the ore is a mining artifact, but then there's things like the mining drill core samples that you'll find sometimes at Sterling Hill with fluorescent minerals in them. And where they have drill cores, they also have drill holes. So there's there's what's left of a piece of ore. Processed ore. This is a piece of copper. Remember those sheet copper I mentioned before that has gone through the rollers in the processing of the ore. and you'll see all these little needles of willemite are crushed into it there. Of course, when they were done smelting the ore, they would create ingots or pieces of zinc for industrial use. You can still collect ore samples that way. Speleothems, remember I mentioned post-mining artifacts. They are growing in the mines, or they were until the mines flooded. You could find these stalactites, stalagmites, and cave pearls. And if you cut the cave pearls in half, they have a little tiny core of fluorescent red and green ore. And they fluoresce. Long wave, short wave. Mineral art. This is unique to Franklin in a way. The miners used to take crushed ore and create these artworks that glowed in the dark with fluorescent lighting. Some of them would take and fill bottles with crushed ore, different kinds of ore, and using tools, needles, or whatever, they would manipulate these to create a pattern. They don't fluoresce really well because the glass gets in the way. You can't get the full effect because the glass is reflecting and not letting all the UV light through. Lapidary is popular. People take and cut ore. They create spheres. And last but not least, concrete. Why would you collect concrete? This is Franklin concrete from the Trotter dump, they called it. And New Jersey Zinc Company didn't waste anything. They used the sand from the mining operation, and they used aggregate, would be chunks of brick, leftover ore, calcite, andronite, garnet, fluorescent minerals. So the concrete's beautiful if you can find some. And that's been slabbed, it's been cut on a big rock saw to show off the fluorescent minerals. Okay. That is my presentation. And I'm hoping I can get back to the multi-view. There they come. And certainly Ken or whoever's in charge of the sound system, if you could unmute that. Thank you.
Everybody is in charge of their own sound system. So
Okay.
they need to unmute whenever they'd like.
Okay.
Thank you, Jim. That was fantastic.
Oh, I hope I didn't just blather on.
No, it was very good.
I have a question. With the scheduling of this in terms of Christmas colors and diversity and so forth, I'm looking at some lights out the window here from my room. That was a splendid December.
Yes, the red and green. The red and green is ubiquitous.
Spectacle of colors and the wonders of nature. Thank you. Fantastic.
Sure. In fact, collectors, jaded Franklin and Sterling Hill collectors, just call all of the rocks that have willemite calcite combinations, we just call it red and green. $2 a pound, red and green. You can go there, you can still go there and collect it if you have a good hammer. I wonder if I show you this, can folks see the what I'm showing here?
Yes.
Yeah.
That's much bigger than I
that
thought it was.
this is that gray willemite crystal that I was showing.
Dang.
It's not small.
No.
There were legends or stories of people finding, miners blasting and mucking out the ore, finding willemite crystals that were 6 foot long, 6 foot like this, the hexagonal crystals. So I've never had an opportunity to own one of those. Any other questions?
I have a question, Jim.
Yeah.
Ken Rock here. What's a better place to collect? Is it Franklin, or is it better to go up to Sterling, go down to Sterling Hill and collect there?
I have a preference right now. Sterling Hill, Mine Run Dump. You can still find a better variety of minerals. And if you don't mind cracking rock, you really need at least a crack hammer and preferably a sledgehammer to break up some of the bigger pieces. You can still find some really, really pretty fluorescent mineral specimens. You'll also find rocks that have beautiful slicken sides. The faulting has left a black mirror surface on the rock, and it's natural. I've always liked those. If you collect at Franklin, you've got to trek up and down that horrible hill down to the buckwheat dump. Some of you know what I'm talking about. It's a really painful hike. And lately, about 95% of the rock that's in the buckwheat dump behind the Franklin Mineral Museum is calcite, which is great. It's very fluorescent calcite. It's lovely stuff. You don't need too many pieces in your collection.
Where would you be more likely to find a zincite crystal?
Crystal zincite, I've never found one, but Sterling Hill would be the better bet for zincite. You can find massive zincite there and platy zincite that I mean, when they say platy, it looks flat and layered. But yeah, zincite crystals are very, very hard to come by.
Is there collecting at night, or is it just catch as catch can to find the fluorescence?
Both of the museums, the Sterling Museum and Franklin Museum, host night digs throughout the summer. Yeah. And again, pros and cons. If your favorite way of collecting is with a 16-pound sledgehammer, night digs are horrible. You hit the rock, it goes flying off into the dark. You never see it again. You know, it's just not safe. But yeah, if you've got a good lamp, then prospecting at night is a lot of fun.
And they also light up Sterling Hill at night too, sometimes with the entire face. They have these gigantic lights and the entire face is lit up. It's an experience to see.
The entrance to the
fluorescent
Noble
lights
Pit.
or regular lighting?
No, black lights. They use I think I don't know if it's Longwave or shortwave, but the entire hill glows.
Shortwave, it's a big commercial light. It's, hundreds of watts of shortwave UV. But yeah, they light up the whole wall.
So if it's appropriate, I just wanted to point out this type of light I have.
Yep.
3 of them. I think it's showing backwards, but these are great UV.
They're great weapons.
It's important
Awesome.
to get one that has UV filter glass instead of clear glass in the flashlight.
The Steinbeck Engineering do. You can get them at Perky Boxes. I'm not a paid representative. Just want to help the world get UV lights.
Yeah.
Do not use one of those in your bathroom.
You don't want to know.
fine.
Yeah.
Or hotel.
Or a hotel bathroom.
The police use them as a forensic tool.
John, what was the name of those flashlights again?
Steinbeck Engineering. You can get them at perkyboxes.com.
Turkeybox.com.
Yeah.
Anybody
they're
have
in
show
stock.
and tell?
Yeah, it's interesting that if you have an issue with a shipment or an order, you send an email and Sean Steinbeck, the owner of the company, will respond to you.
Could you put that in the chat? Could you put that in the chat?
Yes, I will.
Thank you.
Yeah, I'm sorry. I said that I would try and answer chat questions, and people were chatting, but fortunately other members of the club were answering the questions, which is great. Thank you very much.
Yep.
There was a question about uranium minerals. Thorutite has been found at Franklin, which is a radioactive mineral. It's a black crystalline mineral. That's the only 2 I know of. And there may be others.
Sorry, our president is cooking dinner.
Oh, okay.
I smelled something burning in there. I figured I better take a look. So, well, Jim, that was fantastic. I've loved collecting at Sterling Hill and Franklin. I recommend them both. If you drive all the way up there, they're only 2 miles apart. So you can spend a weekend up there and really enjoy both ore bodies. And they have different minerals. Franklin is pretty picked over. Unfortunately, you won't find a lot of hardystonite or sphalerite or any of those things, but I have found them all. But I've also gone up there for years. So, and Sterling Hill, they used to let us up in the dumps in the back. And on certain occasions, they'll still let people back there, but very limited. But it's a great place to go. And if you like fluorescent minerals, it's well worth it.
Well, the mine tour is great.
Fantastic.
If you watch the if you watch the event calendars, you can pick a weekend when they're having one of their either a mineral sale at the museum or a show with dealers, and you can combine going to a show with digging on the dumps with taking a mine tour. Could be a fantastic experience.
Yep.
The Sterling Hill mine tour, I think he just showed a photo of the locker room.
Yes.
The locker room, and then down at the end of the mine, they've got donated minerals that are like this big, crystals that are this long. I mean, it's like the most, and it's just sitting on the bench.
Yeah.
Next to 20 other specimens. It is absolutely unbelievable, that Sterling Hill mine tour.
Yes.
And if you go, some of the tours are led by some of the actual miners who actually were there.
Yeah, there are a few of them still around.
Well, I wasn't that lucky.
I remember we had a tour with a guy named Gordon years ago.
John,
many years ago, we had a field trip. I think it was this club rather than like the Northern Virginia club, up to Franklin and Sterling Hill. We actually rented a bus with a driver and stayed in a motel overnight, and so got to collect at several of the dumps, and took the mine tour, visited the museum. So, a wonderful trip. So,
yeah, highly recommended. Catherine asked, "What causes fluorescence?"
Franklinite crystal about that big. I should have gone downstairs and pulled it out. So.
Yeah, no, you can still find at Sterling Hill. You can definitely break rock and still find Franklinite crystals. Yeah. So someone asked you, what causes fluorescence? That's my next presentation, right? The next 45 minutes. But short answer is impurities in the minerals. And for calcite, for example, manganese, a certain percentage of manganese, like 3 to 5 to 7% manganese in the calcite, causes the crystal lattice to take a certain shape. And when you put light into it, the light comes back out at a different wavelength. And that's the fluorescence.
Physically, what's happening is that the UV light kicks the electrons up to a higher energy state, and then they relax to lower their energy, releasing a photon, but they don't necessarily relax to the same state that they had started out in, which is why it's a different color. So.
Jeff knows what he's talking about. He worked on
the
spacecraft to analyze Mars, correct, Jeff?
Uranus and Neptune. But we were working in the infrared.
I would be remiss if I didn't share 2 of my gems from Sterling, one from Franklin, one from Sterling Hill.
Wow.
Oh, wow.
Wow.
Oh.
This is Franklin. This is not Sterling Hill. This is Franklin. So this thing weighs a ton for its size. And it's a complete crystal, which is awesome. And this apatite just recently joined a collection, and this is from Sterling Hill, and it was collected in the 60s. I love the label it came with: "Snuck under the fence to collect this." was the label that came
Wow,
with.
yeah.
Dan, what was the black mineral in your right hand?
That's Franklinite.
Franklinite.
Yeah, that's a solid Franklinite.
Octahedral crystal.
Glad
Yeah.
that didn't make it into the crusher.
I will also say this is the most expensive rock I own.
Mhm.
Really?
Yes.
Well, I couldn't have Dan show me up without showing a Franklin crystal that I have
Yep, my matrix.
on Matrix.
Oh.
And last but not least, a beautiful rhodonite.
Oh,
Man,
Wow.
And
why
this
don't
came
you
from the
stand?
Patterson Museum in New Jersey. But you can see the big, beautiful crystals on there. This is one of my
Crazy.
favorite. Just the color is spectacular.
Did you
So-
find that, Kenny?
No, found it with my charge card,
Right.
the silver pick.
What they call the silver pick. Yeah.
Yes.
Silver pick.
Did you say those were rhodochrosite crystals?
Rhodonite. Rhodonite.
Rhodonite. Okay.
And one
Yeah.
of the few non-fluorescent Franklin minerals that everybody likes to collect.
One of my favorites. Yep.
I forgot I have one more. So this guy is actually Franklinite, but it's the one that contains tons and tons of iron.
Oh.
I forgot what it's called, but I like that one too.
That's quite a bookshelf, Dan.
Yes, excellent background.
Got to keep it somewhere.
Well, thanks, folks. I don't know if your meeting carries on after the presentation, but I appreciate the chance to show off.
So much.
Thank you.
Thanks. Really appreciate you coming in and giving this presentation, especially at such a short notice.